This paper delves into optimizing hard prompts through few-shot metaprompting, leveraging large language models, LLMs, to generate better prompt templates without revealing the underlying context. The authors propose an iterative method to generate better templates using an LLM from an existing set of prompt templates, exploring multiple methods of optimizing prompts using the LLM itself, including the regeneration method. Two types of feeder methods are used. Feeder method A, which samples the top-end manually written prompt templates with the highest scores, and feeder method B, which samples the top-end and bottom-end manually written prompt templates with the highest scores. These methods are tested for their ability to maintain diversity without stagnation. The paper demonstrates a 103.87% improvement using the best-performing method, showcasing the ability of LLMs to maintain syntax while learning to replicate linguistic styles. The results highlight the impact of linguistic styles of prompts on their outputs using metaprompting. The authors also study the nuanced aspects of prompt engineering, specifically for templates of contextual prompts, to generate enhanced templates. The research builds upon existing research in prompt tuning, including soft prompt tuning and hard prompt tuning, exploring the concept of metaprompting, which involves asking the LLM itself to design prompts, and highlights the importance of using LLMs to optimize natural language instructions to mutate prompts and produce better quality answers while preserving the underlying meaning and human readability of the prompt. The experiment compares the effects of different feeder and propagation methods on the performance of a large language model, LLM, in generating prompt templates, focusing on question answering, summarization, and dialogue summarization tasks. The results indicate that the propagation method is more crucial than the feeder method, with methods using propagation method B outperforming others. The similarity scores show a drastic drop in the first few iterations, suggesting a loss of diversity, but all methods converge towards the end of the 10 iterations. The study highlights the importance of the propagation method in optimizing prompt templates and suggests that further exploration of different methods could lead to deeper insights. The research paper emphasizes the significance of establishing rules and metrics for evaluating prompts, particularly in the context of language models. It presents a comprehensive study comparing different feeder and propagation methods for generating prompts, focusing on tasks such as question answering, summarization, and dialogue summarization. The findings indicate a substantial role played by the feeder method, propagation method, and their interaction in optimizing prompts. For instance, the combination of feeder method with certain propagation methods shows better mean and maximum scores compared to baseline sets. The study also highlights the possibility of the lowest performing prompt scores pairs not having an effect, suggesting that negative metaprompting might be futile in certain cases. The results are visualized through figures, showing the mean scores and similarity scores over iterations for each task. The experiment concludes that method C is the most effective at optimizing prompt templates. Future work could involve extending the study to multiple language models and different combinations for a more generalized result. The paper further discusses the optimization of prompts for language models through extended experimentation. It evaluates the performance of various methods on 42 random data points from the datasets mentioned in section 3.2. The best-performing methods, C, FAPB, and D, FBPB, are used to check the robustness and extent of optimization. The results show an improvement in the ROUGELF1 score and mean scores over iterations for both question answering and summarization tasks. Figures 12, 13, and 14, along with tables 4, 5, and 6, provide visualizations and detailed scores for each iteration. The paper highlights the effectiveness of the proposed methods in optimizing prompts, leading to better performance in LLMs. The authors present an analysis of similarity scores and maximum scores for 3 tasks: question answering, summarization, and dialogue summarization. Figure 14 shows the similarity scores for each batch over iterations, comparing method CFAPB and method DFBPB. The results indicate that method CFAPB exhibits lesser similarity within a batch of prompts, while method DFBPB shows an increase in similarity from the original set of prompts. Table 6 displays the similarity scores for the task of question answering in summarization, extended experiment. The authors observe that the methods that improve over iterations use the same propagation method B. This suggests that sampling a few prompts with their scores each iteration works better than sending the consolidated ranked list of prompts with their scores. The authors also analyze the maximum scores for each batch over iterations, as shown in Figure 15. Tables 7, 8, and 9 display the maximum scores for the tasks of question answering, summarization, and dialogue summarization, respectively. The results indicate that half of the methods improve over iterations, while the other half do not. The authors provide examples of prompt evolution in Table 10, showcasing the first manual prompt and an improved prompt from the latest iteration. This demonstrates the effectiveness of the proposed approach in generating diverse and high-quality prompts. The authors' findings suggest that using the same propagation method and sampling a few prompts with their scores each iteration can lead to better results. However, more data sent to the large language model, LLM, does not guarantee better results in this case. The author's approach has implications for prompt engineering and linguistic diversity in LLMs. Additionally, the authors present a series of prompts from the first and last iterations of a research project, categorized into 4 tasks: question answering, summarization, and dialogue summarization. Each task has its own set of prompts with varying levels of difficulty, as indicated by the precision, recall, and F1 scores. These prompts are designed to test various aspects of natural language processing, including question answering, summarization, and dialogue summarization.